Hello everyone, today I will be going to teach you about what is Hamming code. So basically Hamming code is an error correction system that can detect and correct errors when data is stored or transmitted. So this is a question that comes for 10 marks, that is correct this code 10101011 given to us that the error is at 10th bit. Remember, this is the code that the senders want to send to its destination address. So given to us that while the message is being transferred, there is an error at 10th bit. So we need to verify that the error is at 10th bit or not. So the first step that you need to follow to solve this Hamming code question is that you need to find the total number of redundant bits. Here redundant bits are called parity bits, means which are the wrong bits, error bits. So to calculate how many redundant bits are present here, the formula is 2 raised to power r greater than equal to r plus n plus 1. Here r is equal to redundant bits and n is equal to total number of bits present. So look, in this question, count the total number of bits which are present in this. Look, there are 1 2 3 4 5 6 7 8 bits are present in this code. So the total number of bits are present here 8. Now you have seen that redundant bits I have written here 4. So why I have written here 4? Because we will take an assumption. We don't know the value of r here, so we have put a value here. So 2 raised to power r greater than equal to r plus n plus 1. Let's say if I put r is equal to 1, when we solve this we get 2 is greater than equal to 10. This is not universally true because 2 is always less than 10, so this condition is false. Similarly, we do for 2, we get 4 is greater than equal to 11, which is false. Now when we put r is equal to 4, you get that 16 is greater than equal to 13, which is true always. So we have got r is equal to 4, which is total number of redundant bits are 4 here. So the total number of correct bits which sender wants to send is 8 plus 4 12. Remember, the total number of bits which the sender wants to send is 8. This 8 plus 4 12. Now coming to the tables part, which is very important step in this Hamming code. After doing this completing this Hamming code step 1, now we will move to the further part, which is the tables part. So we are now on the tables part. For that you need to remember the question and the error at which bit was there. So the question given to us was 10101011 and the error was at 10th bit. So you need to work on 3 tables simultaneously. I have named this yellow table as step 2, this is my step 3 and this is my step 4. Here you need to work on these 3 tables simultaneously. You need to prepare these tables in your exam as well. So the first step is, now look, I have written here R4, R3, R2 and R1. This R3, R4, R2 and R1, these are my redundant bits. There are 4 redundant bits, so I have written here till up to 4, R1, R2, R3 and R4. Now look, now come to this step 3. Leave this table for a while. Now come to this step 3. You have to prepare these 3 tables simultaneously, okay? Now come to this step 3. We don't know the value of R4, R3, R2 and R1. Now look, the total number of bits that the sender want to send is 12. So I have written here from right side, starting from right side 1 and ending till 12. Now you have to fill this table. Now the code given to us is 1 0 1 0. Now look, we don't know the value of 8 here. Why I have left here 8? Because 4 redundant bits are present here. So 2 raised to power 0 1, 2 raised to power 1 2, 2 raised to power 2 4 and 2 raised to power 3 8. So these are the positions of the redundant bits. These are always calculated in 2 raised to power something value, okay? Now we are not sure that what is the value of R4, which is 8th position value, so leave it as it is. Come to 7. Now I filled 1010, the next is 1 0 1 and 4 is redundant space and 1. Look, I filled the 8 code which was given to us, 1010, leaving the redundant bit space. Now main task is to complete this step 3 table. We have to know the value of R4, R3, R2 and R1. How we will get this table? By completing this table, step 2 table. This is yellow table. So how will you fill this table? Now look, R4 value is 8, R3 value is 4, R2 value is 2 and R1 value is 1. These are the position 8 4 2 1. It is already written here. So now you will fill this column in column wise manner. Okay, now come to this R1. You will fill this column in this manner, starting from 0, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 and 0, starting from 0. Now you have to until 12 only, because total number of bits present are here 12. Don't start from 1. The position need to start from 0 only. Look, I've written here 0, 1, 2, then I have started. Don't start from 1 here. Okay, start from 0 and until 12. Now where it will, the code will end, stop where it. Okay, now look, come to this R2. After going to R2, you have to follow this pattern. 2 times 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. You have to fill this column to 12 only. Now come to R3, which will have a difference of a pattern of 4 times 0, 4 times 1. 0, 0, 0. Don't remember, you need to start from 0 only. 0, 1, 1, 1, 1, 0, 0, 0, 0 and 1. Now come to R4. Now you have to fill this column in the pattern of 8 times 0 and 8 times 1. 0, 0, 0, 0, 0, 0, 0, 0. Now 1, 1, 1, 1, 1, 1. The pattern in R1 column is 0, 1, 0, 1. In R2 is 0, 0, 1, 1, 0, 0, 1, 1. And R3 pattern is 4 times 0, 4 times 1. And R4 pattern is 8 times 0, 8 times 1. After completing the step 2 table, now come to the step 4 table. Now remember, now you need to know this position of R1 with respect to its ones value. Now look, first you need to prepare R1. Look at this R1 column. In R1 column, find the position where 1 is coming. I will repeat once more. In R1 column, name the position where 1s are coming. Now look, at one position, 1 is coming. So right here in the position value 1. At 1 position 1 is coming. At 3 position 1 is coming. 5 position 1 is coming. 7 position 1 is coming. 9 position 1 is coming. And 11 position 1 is coming. Look, at 11 position 1 is coming in the R1 column. At 9 position 1 is coming at the R1 column. And at 5th, similarly at 5th and 3rd 1 is coming. Now look, similarly you need to fill this R2. Now come to this R2 column. You will see here at what position 1 is coming. So look, at 2 position 1 is coming. So right here at 2 position 1 is coming. At 3 position 1 is coming. At 6 position 1 is coming. 7 position 1 is coming. At 10 position 1 is coming. And at 11 position 1 is coming. Similarly for R3, coming to R3 column. At 4 1 is coming. At 5 1 is coming. 6, 7 and at 12 1 is coming. So come to R4 column. R4, the ones coming are in the position of 8, 9, 10, 11, 12. So right here 8, 9, 10, 11 and 12. Now after doing this, now this the position you will need to know from this table, and the value you will get from this step 3 table. I will repeat once more. The position you will get from this yellow step 2 table, and the R1 values you will get from this step 3 table. Now look, if you don't know the value of redundant bits, now look here, R4 is equal to 8 position, R3 is equal to 4 position, R2 is equal to second position, and R1 is equal to 1 position. I have written here R1, R2, R3 and R4. Now in this step 4 table, the green boxes are the value of this redundant bits. So we don't know if I at 1 position, is there any value given here in step 3? No. We will find it. How we will find it? Now leave this first block, first cell. Now come to afterwards this third at 3 position. Now look, at 3 position 1 is there. So right here 1. At 5th position 1 is there. And at 7th position 1 is there. At 9th position 0 is there. And at 11th position 0 is there. Similarly fill this rest of the column, rest of the rows. So at R2, 3, 1 is coming, 6, 0 is coming, 7, 1, 10, 1, 11, 0. Now coming to R3, at 5th position 1 is coming, 6th 0, 7th 1, 12, 1. Now R4, at 9th position 0 is coming, at 10 1 is coming, at 11 0 is coming, and at 12 1 is coming. Now after filling this all this step 4 column values, now look, now we will need to get the value of 300 bits. How we will get this? By using the concept of even parity. Now look, in this row, check how many ones are present here. Look, in this row 3 ones are present here, so 3 ones, remember 3 ones are present here, so 3 here is an odd number, 3 here is an odd number. One main concept of even parity is to make it even. To make it even, we will add 1 here, so the first value I will place here is 1. So how many ones are present here? 1. Now similarly fill this R2, R3 and R4. Now look, in this R2 row, how many ones are present here? Similarly here 3 ones are present here, this and this, 3 ones are present here, so make it even, I will mark it as 1, add 1. Now coming to R3, here also 3 1 are present here, I will write here 1. And coming to R4, now look here already 2 ones are present here, this one and this one, so 2 ones are present, and 2 is already even number, so we don't need to add 1, so mark it as 0. Look, the computer only understands the language of zeros and ones, so we will fill this column only according to the way of 0 and 1. Now look, we have got the value of R1, R2, R3 and R4, which is our first cell. Now look, at 1 position 1 is there, so right here at 1 position 1 is there, and R2 at 2nd position 1 is there, and at 4th position 1 is there, and at 8th position 0 is there. Now look, you have completed the total code of 12 length to receiver side. Now this is the code that the sender wants to send, this is the code that the sender wants to send to the receivers. We have completed this 12-bit length of code. Now we will repeat this step for the receiver side as well. Before doing that, now you have to note a pattern. A pattern to be noted is here that the pattern of R1, R2, R3, R4, which is top to bottom approach, that is the pattern which is 1, 1, 1, 0. The green boxes, I'm talking about the green boxes. The pattern here followed is 1, 1, 0. Look, 1, 1, 1, 0. I'm talking about this. The pattern here is 1, 1, 0. You have to note this. Now coming to the receiver's end. Now look, when I started the question given to us that correct the code given to us that the error is at 10th bit. The error was at 10th bit. So look, the code is similar. The sender want to send this code, but the error is at 10th bit. So copy this step 3 column to this step 4. So at 12th value 1 is there, at 11 0 is there. Now look, the error was at 10th bit, so this 1 is wrong. So to make it correct, converse, if 1 is there, we will make it 0. Now look, here 10th value was 1, but the error was at 10th bit, so we will change it to 0. Here was 1, now we will make it to 0. Now all are similar, so 9 is 0, 8 is 0, 7 is 1, 6 is 0, 5 is 1, 4 is 1, 3 is 1, 2 is 1, and 1 is also. After completing this table, you need to repeat this steps 6 again. Now a easy step to be followed is that, now look, you will get this Hamming code in a very easy manner. I will explain you in such a manner that you will never forget. If you will do the steps simultaneously while I am explaining, you will get everything that I am explaining in this video. Okay, so do this question with me particularly, and when you get, if you're not getting understanding my question or my explanation, so pause my video and write and see where I'm making my mistake. Okay, now look, coming to this step 6 table. Now look, you don't need to just remake this step 2 table. You need to only copy this step 4 table, because the error was only at 10th bit. So where it is 10 value, 10th position value, we will only make changes on that. Now coming to this R1. So what are the positions R1? Here is 1, 1, 3, 5, 7, 9 and 11. R2 positions were 2, 3, 6, 7, 10 and 11. Now coming to this R3 row, the positions were 4, 5, 6, 7 and 12. Now R4 positions were 8, 9, 10, 11, 12. Now look, the error was at 10th bit. We have only changed the 10th value, right? So now look, is there any position of 10? No, so no changes will be there. The same that I have done in the above step, copy that. The pattern was 1, 1, 1, 1, 0 and 0. Now come to this R2. Is there any position where 10 is coming? Yes, 10 is coming in this. So leave this first block, this green block. Now look, at 3 1 was there, at 6 0 was there. Follow the same concept that we have done before. At 7 1 is there, and at 10, look, at 10 we have changed. Now 10 is now 0. So right here 0, and at 11 0 is there. Now come to this R3. Is there any 10 coming here? No, not coming here. So right here, follow this, copy everything. 1 1 0 1 and 1. Now come to this R4. Look, is there any position of 10 coming? Yes, 10 is coming. So leave this first block, first cell. Now at 9 0 is coming. At 10, look, at 10 we have changed. Now the 10 is now 0. So right here 0. Now at 11 0 is coming. At 12 1 is coming. Now we will again follow the concept of even parity. R1 is complete. R2. Now look, in this cell, how many ones are present here? So there are 2 ones are present. The 2 is already even number, so we'll write here to make it is already even, so we will write here 0. If it is already even, write there 0. If it is not even, then add 1. Okay. Now look, in this cell how many ones are there? Only one is there. So 1 is odd number. To make it even, we will add here 1. Now copy the pattern that is followed here from top to bottom. Remember, from top to bottom the pattern is 1 0 1 1. So top to bottom is the pattern followed here is 1 0 1 1. After getting the pattern, this is the pattern that we got from the sender side, and this is the pattern that we got from the receiver side. Okay, I will write here, this is the pattern that I got from sender, and this is the pattern that I got from receiver side. This is my sender side code and this is my receiver side code. Now we will do the XOR operation. So XOR operation is very easy. So look here, if now this is the concept where we do addition, subtraction in the computer wise manner. Okay, now look, if the code is from top to bottom 1 1, the output will be 0. 1 0 is there, 1 will become 0 1 is there, 1 will come. And look, if 2 digits are similar, 1 1, the output will be 0. 0 0, both are similar, the output will be 0. If 1 is different and 1 is different, the output will be 1. So look, 1 0 is there, 1, 0 1 is there, 1, and 2 0 0 is similar, so the output will be 0. 1 1 are similar, the output will be 0, because we will do this step in the XOR operation. Okay, now look, the pattern that we have got in A, which is sender address, which was 1110. So right here 1110, and the B was 1011. Now result. Now we will do the addition, or we can say a mathematical calculation, by using this XOR operation table. Now look, starting from right side, we will follow the column wise manner. Now look, from right side A is 0 and this is 1. I'm talking about this from right side. Okay, 0 on right side, 0 and 1. So 0 1 is 1. So right here 1. Now I'm shifting my left arrow key, and 1 1, they are similar. Starting from right, okay, 1 1 it's 0 because they are similar. Now 1 0 is 1 and 1 1 is similar, so right here is 0. The pattern that we have got is 0 1 0 1. This is similar to what we do in addition. Okay, don't need to worry. I'm shifting from right, starting from right. Look, 0 1 1 is there, 1 1 0 is there, and 1 0 1 is there, 1 1 0 is there. So this is the pattern that we got, which is 0 1 0 1. Now look, the pattern that we have got 0 1 0 1, after doing the XOR operation on this, we will convert the output that we have got. Converts means we will reverse. Okay, the reverse of this 0 1 0 1 is 1 0 1 0. Look, at 8 value I will write here 1 4 0 1 and 0, because the pattern that I have got is 0 1 0 1. I have to convert this now. 0 1 0 1, to convert this we have got the pattern of 1 0 1 0, because 0 opposite is 1, 1 opposite is 0, 0 opposite is 1, and 1 opposite is 0. After doing this much step, now we have to solve this equation. The 8 4 2 1 are the position values. Look, this is 2 raised to power 0 1, this is 2 raised to power 1 is 2, this is 2 raised to power 2 is 4, and this is 2 raised to power 3 8. Now we have to solve this. We will solve this by multiplying the above cell with the below cell. Okay, now look, the output here will be 1 multiply by 8 plus 0 multiply 4, 1 multiply 2, and 0 multiply 1. When you will solve this equation, which is 1 multiply by 8, what is 1 multiply by 8? 8. And what is 0 multiply by 4? 0 multiply 4 is 0 only. You don't need to write that. And 1 multiply by 2 is 2, and 0 multiply by 1 is 0. So what we will be getting, the output is 8 plus 2 is 10. 8 plus 2 is 10. Remember, the code was at error bit, so this Hamming code has detected that the code was at error 10th bit. So this is how Hamming code works. This complete step is performed internally by the computer. So because Hamming code is a technique that is used to correct the error or detect the error. Now look, this is how Hamming code is done. I hope you liked my video. If you like it, then please like, share and subscribe. Thank you.